You get a sense of what's going on. I'll read it out loud for you for those that would rather hear it. It says, a man 6 feet tall walks at a rate of 5 feet per second from a light that is 15 feet above the ground. When he is 10 feet from the base of the light, at what rate is the length of his shadow changing? So our next task then, once you kind of have a sense of what's going on, is to decide, would it be beneficial for me to draw a picture, or is this one of those situations where a picture just doesn't matter at all? What do you guys think? I think a picture is helpful here. So off to the side, maybe we could draw a picture. I will attempt this. It was a pretty good art day in the other class. Hopefully it'll still be a good art day here. So I've got ground. Let's go with flat ground. There we go. Ground. Bless you. And there's my lamp post where the light is located. I'll put a light up here. There's my light. And there's a guy walking. So there's the guy. The other class, he was wearing blue jeans, so I think we'll go with blue jeans again. There we go. Oops. He's wearing a black shirt and blue jeans. Come on. Got black hair too. Okay. Use your imagination. All right. So anyway, so there's this guy. He's walking along. I think we could draw a little bit more to the picture. Did you guys get something like this? I'd like to somehow indicate where his shadow would be. So what I'm going to do is I'm going to draw like maybe a single beam of light going from the light kind of right there at the top of the guy's head. If that's how this is going here, then where would his shadow start?
At his feet.
At his feet, and wouldn't it end just out there in front of him somewhere? So, I don't know what I can do for a shadow here. Let's go with something gray. Oops, that's way too much. Let's go with that and that. Let's see what this looks like. That's not working at all. Oh, it's too small. Never mind. So here is the shadow. There we go. You guys see the shadow just showed up? I'll make it a little bit darker. Does that work? Shadow. Okay. So that shadow is out in front of him. And so I'd say at this point, this is a pretty good representation of our situation in general. There's this guy walking past this lamp, and between him and the lamp, he's making a shadow out in front of him. I think a picture is, you guys were wise in choosing a picture. Okay, so now let's try to put a box around whatever the question is asking us to find. This is what we did yesterday. Try to put a box around whatever the question is tasking us to end with. Macy, did you do this yet?
Yeah.
What'd you do?
What rate is the length of a shadow changing?
Yep, at what rate is the length of a shadow changing? What was your clue that was the thing we should box?
It's in a question.
Yeah, usually a question is typically the way this is phrased, and it's no different here. Okay, so what we typically did yesterday is we then took that and we interpreted it to be like a rate variable, like dy dt or dv dt or something like that, right? So in order to do that, I think we need to go back to our picture and label some stuff. What do you think we should label? How should we label it? Open to suggestions here.
The lamp is 15.
The lamp is 15 feet, and that's important, right? Because isn't the lamp always 15 feet high? That's not going to be changing. So we just put a 15 on there because we know it's always going to be 15.
6 feet.
And the man is 6 feet tall. Yep, so I'll just put a 6 right here next to the guy. So yeah, he's 6 feet tall. That's not changing either. But there are some elements that are changing, right? We probably should label those with variables. What do you think we should label? The base. Which base? Like specifically describe from where to where?
From the lamppost to his feet.
From the base of the light or lamppost to his feet? Okay, so from here to here, what would you like to call that?
B1.
Let's avoid subscripts.
B.
Just a B for, what does a B stand for?
Base.
Okay. So I'm okay with S for shadow, but me personally, my S's end up looking a lot like 5s eventually, right? S, 5, my 5s get a little bit rounded or whatever. So I personally would not label, and you were talking about the length of the shadow, right? I would not label that with an S personally just because of my 5s and S's issue. What other letter could we use? L for length of shadow? Sure. Let's go with L right there.
D for darkness.
D for what?
Darkness.
Darkness. Hey, you go with what works for you, right? If something works for you and you remember it, you could use it better, then that's totally fine. All right, so now let's go back to Macy's idea. She said we're looking for at what rate is the length of a shadow changing. Now, based on that, Macy, and based on how we just labeled stuff, how would you interpret that?
DL.
Good. dl dt. That would be the rate of change of the length of the shadow. And as you identified, that's our unknown, so I would just put question mark, and we'll leave it alone, knowing that that's what we're going to look for in the end. Make sense? Okay. So the next thing we would do is we'd go through and we'd try to underline any rates that might help contribute to finding what we want to find. Maya, did you underline any rates?
Well, he walks at a rate of 5 feet per second.
Okay, so
So we look
walks at a rate of 5 feet. So it's referring to the guy, right?
at- yeah.
So based on our labeling up there, what would you say would be a good interpretation?
dv over dt
Yep,
is 5.
correct. dBdt is 5. 5 feet per second. Of course, what told you that that would be a key rate that we could use? Like what was a key word or words that told you?
Rate of 5 feet. That's why
And
I
the fact that the
underlined
word rate was in there, that might be
Yeah.
helpful, right?
it.
And then, doesn't the units indicate that as well? Feet per second?
Second,
It's a rate? Yeah, okay. Awesome. So then finally we want to go through one last time and try to find the freeze frame moment. Oh, question, yeah.
I'm just wondering how you got the dB dt. Like,
So-
dB.
Yeah, so it's all based on how we labeled it, right? And I would say that this gets a little bit deeper into it, but I think it's a fair question. This man's speed or velocity is 5 feet per second. Don't we have to judge how fast he's walking based upon a reference frame that is not moving? Right? So if you're like, this is a little bit off topic, but I think it's applicable. Like if you're driving down the freeway and you're going 75 miles an hour, and there's a car right next to you and they're also going 75 miles an hour, if you judge your speed solely based on them, how fast does it seem like you're going? 0. And that's a problem because you actually are going 75, but because they're moving, your perception of your velocity is obviously way off, right? And so, going back to this, if we're going to basically reference this guy's rate of walking, the 5 feet per second, we have to judge that based on something that's not moving, right? And the only thing in this picture that's not moving is the lamp post.
Okay.
And so that's why, we labeled from the lamp post to the guy is B. That's the distance from the lamp post to the man. And the way it said it, he was like walking away from the lamp post or the light. And so, labeling that as a B makes a lot of sense because this will enable us then to say, okay, the lamp post is not moving, so we can judge his speed accurately.
Okay.
Make sense? Okay, cool. All right, so the freeze frame moment, we want to circle that. Anybody get a chance to do that? 10 feet, yeah. So what was the key word for you, Pristine, that told you that was the freeze frame moment? When, yep, when he is 10 feet. So I'll just put freeze frame moment is when, what is 10, based on our labeling?
Feet.
Well, the labeling of the picture, you said 10 feet. So what is 10? L, B, B plus L, L minus B, 15, what? B is 10. There you go. So it's really important that we identify what the freeze frame is talking about. Because is it talking about 10 minutes, in this case 10 feet, and does that go with the B, does that go with the L? That would matter potentially. Right? Okay. Awesome. So now, this might be a challenging part, I don't know. We had a little bit of a false start in the other class. We might have a false start or two in here, and that's okay. We basically have T's, which we always have, so we're not going to get too worried about that. But we have L's and B's, and we have 15, and we have 6. This can be challenging. Can you think of a relating equation where we could put it all together to relate it, where something equals something, and we could then use that to finish? What do you think? Yeah, Tyler.
I don't know how to do it, but it's like take the bigger triangle and set it equal to the smaller triangle.
Okay, so you guys, there's clearly triangles up there, right? There's a big triangle, the kind of like the whole picture is a big triangle, and there's a little one off to the right. So you're saying like make the triangles equal to each other? He's like, I was struggling with how to put that, right?
Yeah.
Anybody help him? Who knows? Ratios, set 2 ratios equal to each other. Well, why could you do that?
The ratio stays the same.
The ratio stays the same because the triangles are similar triangles. Okay, let's see if we can do this. Let's help Tyler out because he's like, I think I can do this, but how do I write it down? Like that kind of thing. Does anybody have a suggestion on a proportion, like a ratio equals a ratio that we could write down? Jonathan?
Like 15/6 equals B plus L over L.
What do you guys think? You guys know there's lots of ways to write proportions, right? It could still be true. Is this a way that works? He basically said tall height is to short height as long length is to short length. You see what I'm saying? He did like the 15 is the tall height and the 6 is the short height. So he did tall is to short as long is to short. Does that seem logical? There's other ways to do it. He picked out a good way for sure. You could do something like 15 is to B plus L as 6 is to L. That would be another way. You basically say height is to base as height is to base. That would work too. Okay, so before we make a decision on this, I mean, because who knows? We haven't really made a decision. Was this the right relationship? Because think about it, we're talking about right triangles. How many relationships are there with right triangles? There's tons of them, right? Before we make a decision about this, let's break this down into an easier form. How do you break a proportion down into like a simpler format? Cross multiply. Yep. So we're going to just go cross multiply here and here. So it'd be 15L equals 6B plus 6L. And this is where we're going to make a judgment. We're going to decide Tyler has led us down the wrong road or Tyler has led us down the right road. Okay? Were proportions the way to go? Or did Tyler just totally make us waste time here? In the other class, we wasted a little bit of time. We went down a wrong road. Let's see if this is a wrong road or if it's the right road. Here's how we make that judgment. If this is the right way to go, wouldn't we do DDT next? We'd do DDT next. So if I were to do that, if I were to say, hey, let's do DDT of this, I'm not interested in what it would be right now. Here's all I'm interested in. If I do DDT of 15L, wouldn't the chain rule give us DLDT? It'd be technically be 15 DLDT, and we want to know what that is, right? So we care about that. So that's a good sign, isn't it? Okay. If I were to do DDT of 6B, what would the chain rule spit out on that one? DBDT, right? And I know that one. Of course, there's another L over there, and that would give me another DLDT, and we already mentioned that that's the thing we want. The truth is, Tyler has done it. Tyler! Good work. His idea about proportions was right. Now let me briefly explain what we did in the other class, then I'll get your question. Is that okay? The other class made a good suggestion, and let's see if you can identify with this. They suggested the Pythagorean theorem. They said, hey, couldn't we do base squared plus height squared equals hypotenuse squared? Do you see how that would be an easy thing to see? Right? It's right there. It's a right triangle. Duh. There it is. We ran into an issue. The issue we ran into is with the hypotenuse, right? We didn't have a label for the hypotenuse, but let's say that we just labeled the hypotenuse C. In our DDTing, like when we did DDT of stuff, wouldn't we end up with a DC-DT term?
Yeah.
We don't know what that is, and we don't care what that is. It's just this thing hanging out there. We don't know what to do with it. We don't have a number for it. That's not our unknown. And so we were stuck. We had to go back and try something else. And they came up with this proportions thing like you guys did on the second try. But you guys came up with this on your first try. You could have done area of the triangle, right? You could have started messing around with the angles. But the truth is, if you're honest about it, every time you'd come up with something that you either don't care about or you don't know. And if you end up in that situation, it means you probably picked the wrong thing as far as the relating equation. You okay with that? Okay, so really honestly, if I was going to do DDT of this, which we are, I would simplify it first. Couldn't we just subtract 6L from both sides? So I would go 9L is equal to 6B, just to clean it up a little bit, and then I would do DDT. All right, so I think let's hear some derivatives here. Ashley, if I did DDT of 9L, what would that give me?
9 DL DT.
Correct. If at any point any of this is not making sense, please stop us and we'll talk about it. Doug, how about DDT of 6B?
You got 6 dBdt.
That is also correct. Nice. DBDT, right? It was DT. Okay. So that, in our little analogy with the Blu-ray thing, we just pushed play, right? We just pushed play. And now, we've watched enough of the movie, we watched this guy walk past the lamp, and now we're ready to hit pause, right? So typically the way that we hit pause is to do what? Freeze frame, right? Plug stuff in, right? So let's plug in the stuff we know. You guys mentioned it before. We do know dB/dt is 5. So I'm going to go ahead and write that down. I'm going to say 9 times dL dt equals 6 times 5. What seems to be weirdly missing from this? What do we need to be able to plug in our freeze frame moment? A B. Doesn't there need to be a B in there somewhere? Did we mess this up? Did we accidentally forget where the B should be or something? We didn't make any mistakes, did we? We really didn't. So I want to let you guys know, this situation of the man and the lamp and the shadow, like these types of questions, are unique in the fact that the freeze frame moment won't matter. On almost every other question of this related rates type thing, that freeze frame moment, the pause button, will matter. But on this one, with the proportionality, the reason why is, no matter where this guy is, won't the two triangles be in a proportion?
Yes.
And that's why the freeze frame moment doesn't matter. No matter where he is, the relationship is still going to be the same. You're going to still have the proportion between the triangles. So to finish this off, we would just say dL dt is equal to 6 times 5, which is 30 over 9 when you divide, which is equal to 10 thirds. What kind of units would go with this dL dt? Feet per second. Good. Hey, Mandy, a second ago you had a question.
Oh, you answered it. I was just about combining the like terms of 15 and
Yeah,
6.
and that makes perfect sense. I just didn't want to get too far ahead of myself if it was
Yeah.
bad. But Tyler did not lead us down the wrong road. So, good job. All right. So I hope this goes with experiences that you've had. As you have walked past a lamp, some kind of street light or whatever in the past, don't you see a shadow out in front of you? Isn't it impossible for you to catch into your shadow, right? Just by the nature of what it is. So as you walk, think about this. This guy's walking at 5 feet per second. Well, the length of the shadow is actually getting longer, isn't it? The shadow's getting longer by 10/3 of a foot per second. So for every second for this guy, the shadow gets a little bit more than 3 feet longer. So 5 feet per second is pretty fast, right? Yeah, he's moving along pretty quickly. So he's trying to get somewhere important, I guess. I don't know. Yeah, it's definitely speed walking. All right, so let's skip the stock one next, and let's move on to number 7. We'll do that one, and then we'll come back to the stock one. So please read this one through like we've done before, just get a sense of what's going on. I think you'll pretty quickly see that this is a similar setup to what we did, I think, with number 3 or whatever, the one we did before with the ladder. Right after that, I think you'll see that it starts asking some pretty different questions. I'll read it out loud for you. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. I think that's all the same as the previous ladder question. What is the rate of change of the angle between the ladder and the ground when the base of the ladder is 15 feet from the house? Okay, so task number 1, let's put a box around the thing that we're trying to find and decide, is a picture appropriate or is a picture just unnecessary waste of time? Make a decision on that. Give you a chance to do that on your own. If you want to continue on and underline rates and try to do some interpretation and start to try to put this together a little bit, that's great too. I'll just give you a little time and space to do that. Okay, you guys have had a little bit of time here to do this. Let's try to put a box around the thing that we're asked to find. Riker, did you put a box around some words?
What is the rate of change in the angle between the ladder and the ground and the base of the ladder?
I think I would probably stop it right here, because that next word, when, of course, is its own important thing. But yeah, what is the rate of change of the angle between the ladder and the ground? Did you guys decide that a picture was useful? Okay, so I will try to do a good job of drawing a picture. Hopefully we all agree. There's the wall, there's the ground. My ladder is going to be red, something like this. We probably should label, right? If we're going to try to interpret the thing that Riker put in the box, he did it correctly, of course. We should label stuff, right? So the ladder is 25. McKenna, did you label other stuff? And how did you label that other stuff?
I labeled the height 8.
Okay. Anything else?
Then I did the vertex to the base of the ladder B.
Oh, so this.
Yeah.
Okay, yep, good description. I got it. Took me a second to think about that, but yeah, that works. Okay, so H and B, isn't that kind of what we did before? Okay, did you label anything else? Okay, did anybody else label anything else? Madison?
I did A for the angle, like between the ladder and the ground.
Okay, so right here.
Yeah.
A right there. Okay, why did you choose to label that angle?
Because it says, what is the rate of change of the angle between the ladder and the ground?
Yeah, I mean, it kind of spells it out pretty clearly right there. It does say the angle between the ladder and the ground, and isn't this a big piece of what we're trying to find? Right, what is the rate of change of that angle that Madison just pointed out? So I think we would want to label that one too. What other letters could you use? We'll go with A, but you could use D. Why D?
For like degrees.
We never use degrees though. Ever. In this class, if you find yourself using degrees, you just made a mistake.
R.
R for radians. Somebody said theta. Theta would make sense. You could use X for an angle as well. Theta would be a common one. Thetas are happy, right? I don't know. I like thetas. Yep. Agreed. Okay. So then Riker put the box around that. Is it okay with you guys? I don't know how, if you drew a picture, maybe you labeled it, just so that we can all be talking about the same sort of thing. If you labeled it differently than how we labeled it up there, would you mind changing your labels just so we can all talk about the same stuff? So you aren't talking about X's and Y's, and we're talking about B's and H's, and it could get kind of confusing, right? So anyway, let's go back around to Riker. You identified that phrase that tells us what to find. Based on what we just wrote down as far as the letters and labels and things, what would you say would be the interpretation of that for our unit, our unit variables? DADT? Yes. So DA, let me try that again. DADT, and that's our unknown, so I'll just put, like we've done before, question mark. Fair enough? Okay, so Mandy, did you underline any rates that might help us with this? What'd you underline?
At a rate of 2 feet per second.
Okay, so at a rate of 2 feet per second. And so we're talking about the base of the ladder in that case, right? Okay, so then did you interpret that into the rate variable stuff?
Yes, I did dB dt equals
Okay.
2 feet per second.
dBdt, and you said equals 2 feet per second. I agree. Units are good there. I'll leave them off just for lack of space on my screen, but yeah, dBdt equals 2. And then finally, we want to try to circle that freeze frame moment. Natalie, did you circle the freeze frame moment?
Yes, it's when the base of the ladder is 15.
Agreed. And what was the key word that helped you identify that? When. It's like a very common word that tells you that this is the pause button right here. This is the freeze frame moment. So I will put freeze frame moment, and I want to be really specific here. You said 15 feet. So using our labels, would this be like when H is 15, or B is 15, or A is 15? Say again? B. Yep, that's right. So when B is 15, we want to be very specific about what is what and where things would go. All right. So we're kind of the same place we were with Tyler just a few minutes ago about the, I've got T's, of course, because there's time, but I've got A's, I've got B's, I've got H's, I've got 25. I've got a lot of stuff. I've obviously got a triangle again, a lot of triangles in this so far. The question then is, can you put it all together in just one equation that relates all this stuff? Mark, you had your hand up first. Let's hear what you got.
I said cosine of A equals B over 25.
Cosine of A equals B over, I'm just writing it down right now, B over 25. Okay, so what do you guys think? Does it seem logical? I think there is some logic to it. We'll decide if he did a good job with this in a second. It's logical because isn't a trig function really the only way to relate the angle of a triangle with the sides of the triangle? It's the only way to do that. And so he has related some stuff. So first of all, did he relate the stuff up there correctly? Is the statement up there written correctly? I agree that a trig function is appropriate, right? Did he do it right? I think he did, right? Cosine of A, then he did adjacent over hypotenuse. I think he wrote it down correctly. Let's make sure now. Let's do a final check to see if Mark really did this correctly. By doing let's just mentally do DDT, okay? So if I were to do DDT of cosine A, what is the chain rule going to kind of spit out at the end?
Negative.
No, well, I know the derivative of cosine is negative sign, but it's going to spit out times, wouldn't it be dAdt?
Yeah.
derivative of cosine of A with respect to time would give us a dAdt factor. Do we care about that?
Yes.
Yes, we do. So, good start, right? So far, so good. What about the b over 25? If I were to do ddt of that, the chain rule would give me a times dB dt. So is that bad? No, that's very good, isn't it? That's very good because dB dt, we already wrote that down, is 2. This is exactly why we try to interpret and write stuff down ahead of time, so that as we start to think about, is this all going to work together? We're like, yes, there it is. I know about this, or I want to know about this. Mark, fantastic job. This is well done. Very well done. You have any questions about any of this setup? Do you have a question about this? Do you think to yourself, well, cool, that's good for Mark. He came up with this. I don't think I could. Do you know how you get over that? Practice. You know how you get over that? Is you try and you fail, and you try and you fail, and you eventually try and succeed, and you start to make connections. And then you do it again. And you say, oh, this is impossible. And you try and you mess up, and then you try and you succeed. And eventually you start to see it as quickly as Mark did. And Titus, I don't know if you were thinking cosine there.
What?
Were you thinking trig function also?
Yeah.
Yeah, so you saw it pretty quickly as well. Awesome. Yeah.
So how, would it be okay to do like the A equals inverse cosine?
Hey guys, I think this is worth listening to. I'll try to repeat what you said. Jonathan said, would it be worth it to say A equals inverse cosine of b over 25? That's a true relationship, isn't it? Isn't it just kind of the opposite side of cosine? He just did the inverse of cosine, essentially. That is a 100% true relationship, but you will get bogged down pretty quickly. And the reason you'll get bogged down is because when we did ddt, wouldn't we have to do ddt like the derivative of inverse cosine? Do you know how to do that yet? Yet. You will soon. You will. Oh, come on, it's not that hard. If you know how to do the Pythagorean theorem, you can do it. But that's a topic for a future discussion. So Jonathan, the answer is yes, but that form for right now would not work. In a few months, that would totally work, and maybe would be the better way to go. Yeah. Okay, we good? Oh, yes.
So when you do a ddt of cosine of A, so it's negative sine times dAdt, like what's the negative sign of?
Yeah, can we work?
A. Yeah, well, yeah, we'll definitely work through this. Yeah.
Oh.
Yeah, we're not done. We're far from done.
Oh, okay.
We need to finish this now. I just want to make sure we're settled on this is the right thing. This is the right relationship. Yes, ma'am.
Well, so I know you said it's dAdt, but does it just go away when you're doing
No. So I was not differentiating it. I was just interested in what kind of rate variables would show up.
Oh.
I know there's a lot of details I left out there, and we're not even close to being done. We need to finish this thing still. But I was just kind of curious. I was trying to make a judgment. Was this the right thing? Because what I don't want to do is go all the way through to the end and spend 10 minutes and be like, oh, crap. This is the wrong thing. I'd rather try to make that judgment early and not waste the time. Now that we've decided that, yeah, this thing is probably going to work, now let's go ahead and do all the details. Make sense? Okay. So let's go ahead and do ddt of everything. So let's talk specifics. What is the derivative of just cosine? So this would be negative sine of A times dAdt. So I think this was the question you all were asking. Valid question. There's a trap waiting for you on the other side. What trap is it? Don't do the quotient rule, because the bottom is just a constant, right? The bottom is just a constant. You can do the quotient rule. It'll work. It'll just take you longer than it should. It'll be more of a difficult situation than it should be. So what I would ask you guys to do is, instead of thinking of it as b over 25, please think of it as 1/25 times b. It's the same thing. So I'll rewrite that over here. 1/25 b. It's better. So now that we have that, Maddie, what do you think? ddt of 1/25 b. What do you think that is?
1/25 times dB dt.
That is exactly correct. Nice job. It's easier when you do 1/25 b versus b over 25, right? To me, visually, it just makes more sense. It's easier to see. You can make your own judgment call on that. Well, guys, we are not out of the woods yet. Let's keep going with this. We do know some of this stuff, right? I don't know why I went with a capital B. It should be a lowercase b. But we do know dB dt, don't we? It's 2. Okay, so I'm going to write equals 1/25 times 2 would just be 2/25. I've got my dAdt right here. And of course, dAdt is what I want. But I've got a big issue here because negative sine A. The issue that I have is that my freeze frame moment is in terms of B, right? When B is 15, you look at the input for sine, and it's A, right? So it would be a big mistake just to go sine of 15 and do some division and call it good. That's a big mistake because A is A, B is B. They are different. So this is a challenge. This is going to be a challenge to think this through. What can I do moving forward with this sine of A? Because we've got to plug the freeze frame moment in somewhere, don't we? Somewhere, somehow, some way. We've got to deal with this freeze frame moment. Any thoughts? What we could do? Just take a little bit of effort to come up with this.
Could we do the inverse sign?
Inverse sine. Okay. Okay.
Over, or
So what does, let me ask you this. Yeah, so inverse sine of what?
B over 25?
That'd have to be h over 25, wouldn't it?
Or h
In
over
relation to a?
25,
Yeah, okay. So that would be going down the road of actually trying to find out like the actual measurement of the angle, right? We don't have to do that, and I don't think we want to do that. I think we can skirt right around that. But that's kind of, we're kind of going in that direction. I agree. Your thought? Or was that your thought?
I was going to say, just try and find A when B is 15.
Yeah, so we could do that, and that's like the very much of the pre-calc way. It's like, when pre-calc, it's like, you got some side links, find the angle, right? That's kind of the way we think. We don't have to do that, and here's why we don't have to do that. If we did find the angle, let's say we found out it was like 42 degrees or something like that, or a certain number of radians, what would be the very next thing we would do?
Plug in.
Wouldn't we just do the sine of whatever that angle was? So I don't see any need to actually find the degrees. But you're all on the right track. So let's talk about how we would do this. I'm going to use my picture. Do I have room? I guess I have room. I'll just draw another picture over here. So here is the wall, here is the floor, and it's at the freeze frame moment. So the ladder is still 25, and the freeze frame moment, the base is 15, correct? Okay, so here's my angle A, as mentioned. I'm supposed to do sine of that angle. What's the side ratio for sine? Opposite over hypotenuse. So what's the opposite side here? We don't know right now, but can't we figure it out pretty easily with the Pythagorean theorem? Or maybe you remember it from the other day when we did this. 20, yeah. So this side length is 20. So here's how we handle this. Instead of getting all bent out of shape about what's the measurement of the angle, is it 40 degrees, is it 50 degrees, what is it? We don't really care because what we're going to do is the sine of it, right? So the sine of A would just be 20 over 25, opposite over hypotenuse. So what I would write there for sine of A is I would write negative, because it's negative, 20 25ths. So negative 20 25ths times d dt equals 2 25ths. So the sine of A didn't disappear. Didn't we just do what it told us to do? Find the sine of the angle at the freeze frame moment. We found out that it was 20 25ths, so we just replaced sine of A with 20 25ths. The rest is just a reciprocal multiplication. Any questions on that part right there? Does it feel like each of these questions has ramped up in difficulty a little bit? So I want to remind you of something. If we were to go back right now, and we won't, but if we were to go back right now and do the cube problem, wouldn't you look at that cube problem and be like, yeah, give me 2-3 minutes, I'll be done? Right? Do you remember how difficult that cube problem felt when we first did it? We took like 15 or 20 minutes to do it. I would bet you could do it in like 3 or 4 minutes right now. Give you another week or so to practice for your quiz, you probably could do it in like 2 minutes. That type of question, right? That simplest type of question. So already I think you're getting better. You're picking up on things quickly. Yeah.
So what would the units be for this one?
Well, let's finish it. So wouldn't I multiply by negative 20 25ths on both sides? Or negative 25 20ths, sorry. Multiply by the reciprocal.
Oh, yeah.
So I'd get dA dt is equal to 2 25ths times negative 25 20ths. So conveniently enough, the 25's cancel, don't they? And the 2 and the 10 cancel. So I'm coming up with negative 1/10. So now let's talk about the units. We're talking about an angle, aren't we? Rate of change of an angle, as we identified at the very start. So rate of change of an angle, it's going to be a rate. So it's going to be per second, isn't it? Something per second. What do you think it's going to be? Radians. Yes, it is radians per second. It is not degrees. So I'll just put rad per second. If you never introduced degrees, did you know that radians just happen on their own? It's a comparison of the radius to the arc length of an angle. And so, honestly, degrees are the far more awkward unit. Degrees are based on 360. Seriously? We're base 10, aren't we? So degrees of this 360 thing, radians are just base 10. They're very easy to handle within the context of a problem like this. I don't know, that's my opinion. Hopefully you'll come around if you're not already there. So, Mandy, is that good?
Yes.
Any questions, follow-ups, clarifying questions? We got one more to do, but let's try to leave this in a good place before we move on. Okay, fantastic. Let's go ahead and go back to number 6, the one about the stock price. Like before, let's just read it over, try to gain an understanding of this general principle of what's going on. It says the value of a share of stock in a new electric car company, this value to be measured in dollars, is related to the price of the company's electric car, by that equation right there. If the price of the car is valued at $41,468 right now, but it's dropping at a rate of $41.27 per day, at what rate is the value of the stock changing in 5 days? So in general, I don't know if you guys know much about the stock market. I know very little, but I do know the basic principle of the value of a stock of a company is tied to its product's performance, right? So if you think about it, if you've got a company that's on the stock market and their big product is doing great, might people want to buy the stock? And that would actually drive the price of the stock up. But if their primary product is really terrible and nobody wants to buy it, wouldn't they have to drop the price for people to buy it? And that would drive the price of the stock down. So that's the basic premise of what's going on. Should we draw a picture of this?
No.
What is there to draw a picture of, right? A car? I don't know how that's going to help. Could be entertaining to see us all try to draw cars, but I don't think it's going to help us with this. So let's not worry too much about pictures here. Let's go ahead and take a minute and do the boxing and the underlining and the circling and try to do some interpretations. So let's just take a couple minutes to do that, okay? So ready, set, go. And boxings and circlings and all that stuff. Ashley, what'd you box?
What rate is the value of the stock changing?
Yep, makes sense. At what rate is the value of the stock changing? Again, it's in the form of a question. So are you getting in the habit of that? Like, hey, this is the thing we're trying to find. Usually it's kind of a piece of the question. Yeah. So I'm interested also, Ashley, in how you interpreted that into our rate variables.
I said that was dV dt.
dV dt. I agree. So this one, we obviously didn't draw a picture, and we really didn't label anything either. Didn't they already kind of label stuff for us? V is the value of the stock, P is the price of the car. So we kind of have to go with their letters. Let's not make anything brand new up. So as you identified, Ashley, that is the big unknown. So we'll just put a question mark, and we'll move on. So then Titus, did you underline any stuff, maybe with a rate that we could use to help us?
Yeah, the price is dropping, so like dP/dt is 41.27.
Okay, so price is dropping at that rate. So you said dP dt. What did you say that equaled again?
41.27.
Okay, what do you guys think? It would be negative. Why would it be a negative rate? Because the price is dropping. So if the price is dropping, the rate of change of that would have to be negative. So we'll put negative 41.27. Definitely an important thing to think about there. Of course, if the price of the car was going up, then the rate would be positive. Okay, and then did you see the freeze frame moment, Pristine? What'd you circle?
In 5 days.
So this is unique, right? It didn't say the word when, did it? But you still identified that freeze frame moment correctly. In 5 days, it's kind of like, when 5 days have passed, you could have rephrased that a little bit and still say when. So I agree. Freeze frame moment. What would we put there? Is that when V or P equals 5? What would you put there? T for time, right? When T is 5? Yeah. Okay, so when T is 5, that's our freeze frame moment. Now, what about this question was actually super duper easy? Don't they give you the relating equation? So all that effort we put into like proportionality with triangles and cubes and Pythagorean theorem and trig functions like Mark came up with earlier, we don't have to do any of that stuff here. And I want to tell you guys something. I'd say it's at least a 50-50 proposition, like in an AP setting, that they would give you the relating equation. Maybe more often than not. You're going to have to know the Pythagorean theorem and maybe the proportionality stuff, but a lot of times they'll just give it to you. So that's our relating equation, so I'll just rewrite it down here. Volume equals value equals 0.9886, p to the 0.1314. So we got all of our stuff lined up. We got our relating equation. How do we push play and get this stock doing whatever it's going to do? With respect to time. So we're going to go ddt of everything and see what that gives us. It better work, right? Because they gave us the relating equation. So if it doesn't work, we got an issue. Hey, Dan, what is ddt of v? It is dv dt. I see you, Dan, I see you working on your calculator. Were you doing the derivative of the other side as well? Don't you just use a power rule? Don't we just like drop that 0.1314 down there and multiply it? What'd you get when you multiplied, Dan? 0.1299. Is that where it stopped or did it keep going?
0.0204.
So a little note about this when we haven't done a whole lot with the calculator yet. When you're doing calculator steps like this, and obviously we need to have the P and all that stuff up there, but when you're doing this on an in-between step, which this is definitely an in-between step, you do not want to round. Don't. You can store numbers in your calculator with like the store alpha A or something. I can show you how to do that if you don't know how to, but you don't want to cut it off because if you do, remember you got to be accurate to how many decimal places? 3. Minimum of 3. So if you cut this thing off too soon and then you start to work with it, maybe you round off again later on or something, you almost for sure won't be accurate to 3 decimal places. And listen, there is no you were close enough. You either got it right or you got it wrong. Okay? If you keep all your decimals, you'll be fine. But if you're rounding things off in between, odds are eventually it's going to catch up to you. So please don't do that. All right, and then did you subtract also, Dan?
I did not.
So did anybody do that for an exponent? What'd you get, Jonathan?
-0.8686.
I agree. And then, of course, let's not forget with all those detailed numbers, don't we have to multiply by the chain rule? What would it be? dp dt. Okay, so we know some of this, right? Based on what we wrote down before, don't we know that dp dt is 41.27? Or negative, yeah, thank you, negative. So I'm going to write dv dt at my freeze frame moment, so I'll put at t equals 5 equals 0.12990204. I'll leave a blank for the p right now, so it'd be to the negative 0.8686 and then times negative 4127. Any ideas on what we put in there for the freeze frame moment, the letter P there? What do you think, Mandy? And then put that in for P?
Yeah.
Okay, what does P stand for?
The price of the car, so you take that.
Well, hang on. So if P stands for the price of the car, Mandy would actually be finding how much came off of the car, right? So Titus, you were about to say instead we should do...
You should subtract that from the original price.
So let's talk about that. You're exactly right. The big trap here is, and maybe some of you might have been thinking of this, maybe you weren't, but the big trap is to put 41,468 in for P, right? That's definitely a trap. Because that's how much the car was worth 5 days ago. We want to know how much it's worth right now. 5 days, into the future, really, is what we're talking about. And so what you would do is you would go 41,468 minus 41.27 times 5. And whatever that number is, that's what would go in there for P, the current price of the car. And once you've done that, the numbers are pretty big, but thankfully you have a calculator. It's a kind of a plug and chug situation. Let the calculator do all the work for you. It's going to be a negative number. I think it's pretty small if I remember correctly. McKenna, did you get it?
Not yet.
Not yet. Anybody get it? Just kind of curious. Titus, what did you get? Negative?
Negative 5.250 times 10 to the negative 4.
Yeah, that sounds about right. So yeah, it's basically negative 0.000525. What would the units be on that? dV dt should tell you the units. V stands for value measured in. T stands for measured in. So it would be dollars per day. So the Leibniz units, the dV dt should tell you about, or the Leibniz variable should tell you about your units. So dollars per day.
Wow.
Lot to digest, right?
Yeah.
Keep digesting, keep working. We'll do this again tomorrow. Hope you guys have a wonderful rest of your day. I'll see a few of you in a few minutes.